Our learning goal today, let's go over here first. Harley, over here with me. Tyler, over here with me. Wade, over here with me. Thanks. Okay, it says I can write a function. Another word that really means the same thing as a function is an equation. So when they ask you to write a function, think of it this way. I need to write an equation based on the relationship between x and y. So based on what we determine is being done to the x value, the input, to get the output, we should be able to put together a function, also known as an equation. So I have put that up here. Let's circle that so that you really understand that if they're asking you to write a function, they're asking you to write an equation. Okay? So our directions tell us to write a function for each problem using the variables x and y, like they do in the table, to describe the data in the x and y tables. Remember to put the y on the left, or in other words, we're going to set the equation equal to y. We're going to say the output is the result of what do we have to do to the input. And then we're supposed to check our answer. We're supposed to take our function, our equation, and substitute one of the x values from the table into it to make sure we get the corresponding y value. Okay? So the first thing they say is, what is the function? Well, we're going to leave that alone for a moment. We got to do some work before we can answer that. So the first thing I want you to think about is what is being done to x to get y in that table. Make a decision. Everybody do it. Decide. What is being done to x, the input, to get y, the output in that table? Okay, what is it? Multiply by what?
8.
8. Okay, well let's do that. Let's show that. If we take 3 times 8, we get 24, which is the output. 7 times 8, what is 7 times 8? 56. If we take the next input, 10 times 8, what is 10 times 8? 8. I want you writing these down. The next input in the table is 6. If we take our 6 times 8,
48.
we actually get 48. Okay. And our last input is 2, multiply by that 8. What's that? 16. Okay. So that seems to be the rule, isn't it? Multiply the input by 8 and you will get the output. Okay. So what does not change in this work that we did over here? What's the only thing that does not change? It's a steady, it's a constant. It stays what it is every time, no matter what the input is. Multiplying by 8. Let's circle that. Multiplying by 8 is the part that does not change. So it's going to be something in our equation that is going to be showing that we're going to multiply by 8. No matter what the x value is, we're going to multiply it by 8, and that will give us the result, the y value. So our function then could actually be written, the output, remember they said they want the y on the starting our equation. So y equals, we're going to get the output by doing what to the input? What did we do to the input? Multiply by 8. So how do you think we could show that in the equation that says, write the function that represents no matter which x value you use? What would we write? What do you think? Y equals, so in other words, our y values are right here. Here's y here. What's the other thing that changes in our problem? Don't these all change? And what are those guys? They're the x's. So what are we going to do to get, what should we write in our equation? Wait.
X times y equals x times 8.
Yeah, y equals x times 8. Take the input times 8. The 8 doesn't ever change, but the x changes, and then accordingly to what the x is, When it gets multiplied by 8, that tells us what the y value is. So again, there's always something in the equation that changes. In this case, we have an x value that changes and a y value that changes, but the 8 never changes. That's the rule. Okay, so what we're going to do, though, is we're going to kind of clean that equation up a little bit. Like, how do you think we would see it if they were asking us to solve it? So anybody know how we might see this equation written, as I call it, cleaned up? The typical way? Still going to be y equals. What do you think we can do with that x times 8? Think about how you see equations written that you've been solving. What do you think? Sylvia? 8x, yeah. 8x means multiplication between the 8 and the x also. So that's how we would typically see it written. So we are going to circle that as our function. There's our equation for this table. Okay, now it tells us to check our answer right here. So we're going to write our equation down. And we're going to pick an x value from the table, plug it into our equation, and see if we get the appropriate y. It should work, in other words. So somebody pick which x value you want from the table. Wait. 10. Okay, so we're going to do x equals 10. So y equals 8 times 10. Y equals, I'm making that multiplication job worse every time I try to make it better. Okay, I'm going to eventually get there. And what is 8 times 10, did you say? 80. Okay, so 8 times 10, we get 80. Go up to our table, and let's circle that in the table. Does it check? Is our equation a good equation? Yes, it checks. We get the one that we were checking. We put our x value into our equation, and it better get the y value that was with it in the table. Okay, I want you to totally try this next one on your own. Everything we did up in that one, I want you to do for this one. Hope you're working while I'm working. What's our function this time? Y equals what? 2x. Anybody want to agree with Harley? Y equals 2x. Okay, so the rule is to multiply the input by 2 to get the output, isn't it? So y equals 2x. Okay, you choose which one you're going to check. You get to pick from the table whichever one you want to check if you haven't done that yet. Dad, which one did you check? I'm going to do yours. Which one?
2 times 3.
No, I want an x value. Which x value did you use? 3. Okay. X equals 3. So y equals 2 times 3. Y equals 6. So I go to my table, and I see that, yep, the y value is 6. Seems like it checks out. Anybody check x equals 4? Tyler, Harley, did it work? Okay. Anybody check x equals 10? Okay, did that one work? Yeah, okay, how about 100? Anybody check x equals 100? Anyway, did it work? Okay, anybody check x equals 2? Well, do you think it will? Okay. So questions? Okay, let's go to the back side then. Okay, you're busy. You guys already know what to do. Okay, go. What's happening to the input? Talk to me. What's happening to the input? Multiplying by 3, okay. And again, in your work, I would like you to circle that to show there's always, oftentimes, something that does not change. That better be in our equation then. So you should not even be looking at your table until you have done all of the multiplying the inputs by 3, and then you should check to see if all your y values match up. Then you can feel pretty confident it's time to set up the equation, the function. Okay, who wants to come up here and finish for me? Volunteer to finish mine? Done some of it for you. Hey, Wade, come on up. Try to make it so you don't have to scrunch down. Okay, so Wade says that the function for this one is y equals 3x. Anybody in agreement with this? Okay, I don't want you working on the next one, I want you talking with us on this one. Anybody in agreement with Wade? If I don't see your hand up or a head shake or something, I'm going to ask you what yours is then. Hey, what's yours, Sierra? So you have the same function as Wade, okay. So, how many of you checked the same x value that Wade did? Wade checked x equals 30. You check the same one? Okay. Anybody check x equals 1? Is that a hand up there? Okay. Anybody check x equals 4? Nobody. Oh, you did, Tyler? Okay. How about x equals 10? Anybody do x equals 10? Okay. How about x equals 100? So that was the only one that didn't get checked? Oh, you did, so all of them got checked. Anybody's not checked out? Okay, because it's important that our function really works for the whole table. So we're going to do something a little bit different in this last one, okay? So if you've already started working ahead, you might want to halt for a moment. Okay, so let's figure out the rule. What do we have to do? It's actually called the function rule. What do we have to do to the x to get the y in this one? What do you think, class?
Times 10.
Multiply by 10? Okay, let's try it. 10 times 10, and again, I'm not looking at the table right now, I'm just saying 10 times 10 is what, class? 100, okay. And then I have an input of 2. 2 times 10, what's that? 20, okay. Now I have an input of 300. Take that times 10. 3,000. What's the shortcut for multiplying by 10? Add 1 0 to the, what you're multiplying, right?
Yeah.
Okay, so 1 times 10 should be a 1 with a 0 at the end. Is that true? Yeah, okay. And then 50 times 10 should be a 50 with a 0 attached. What would that be? 500. Okay, now we go look. 100, 100, 20, 20, 3,000, 3,000, 10, 10, 500, 500. Okay, so the constant in this one is the multiplying by 10. Circle that. Because then that says you better have a 10 in your equation. A multiplied by 10 in your equation. So Caden, what would the equation be for this one?
Y equals x times 10.
Okay. Okay, how would we most likely see that in an answer bank? Caden, go ahead.
Y equals 10.
Okay, which would be probably written y equals 10x. Okay, so here's what we're going to do. All of us are going to check all 5 input values. Because we're feeling pretty confident we know what we're doing, but we're just going to make sure then that y equals 10x. So we're not going to write down all the x values. We'll just say y equals 10 times the first x value, which is 10. Y equals 100. Check. When I put 2 in, I get 20. I go up to the table, 220. Check. Okay, do all 5 of them like that. Do it. Okay, we're going to do one more thing. Yeah, did they all check out on your papers?
Yes.
They all checked out on mine. Okay, right now we actually have 5 ordered pairs. What do I mean by ordered pair again? What's an ordered pair? Dig back in some notes if we have to. I'm telling us we have 5 ordered pairs. What do I mean by that? Every function has ordered pairs that belong to it. This one right now, we have found 5 of them. This function, y equals 10x, actually has an infinite number of them, but we actually just found 5 of them. Caden? 5 equal groups. Okay, that's not necessarily what an ordered pair means, but we did end up with 5 equalities, yes. Open your binders, find something about ordered pairs. I'm not telling you what it is, sorry. Want to try again, Steve? While they're looking at you,
No, it's 2.
you're just thinking. Ordered pairs.
Well, I'm just thinking.
You got a lot of notes, don't you? Yeah, you got a lot of notes that probably are worth having in your current stuff, like
Nope.
finding volume. Haven't been doing that for a while, have you?
Nope.
No. You're good about quick Anybody find anything yet? You still don't know what order pairs are? Oh, this is a sad state of affairs. Well, I'm not giving in, and we're not gonna move on to homework until you tell me and we can bring them all down, so.
Okay, so which one goes down?
Let me give you a little hint. Ordered pairs are placed on a coordinate plane. Well, I'm not gonna keep my recording going because this is apparently gonna take a while.